So today we will continue with the next method for solving linear equations, systems of linear equations. It's going to be the Cramer method, or also called the Determinant method. So we will see it today for a 2 by 2 system. A determinant, it's a rectangular array of a matrix. I know that we haven't seen many about linear algebraic stuff, but I will explain only what you need in order to solve these kind of exercises. So the determinant will have an array like this. It's going to be only values here, a, b, c, and d. They are numerical values, coefficients. And in the way for obtaining the determinant, we need to use like a cross multiplication, ad positive minus bc negative. So it's going to be very easy. The determinant will be always obtained like a cross multiplication, AD positive minus BC negative. Remember, we need to have an ordered system. The ordered system is composed by x, then y, then the value. So we will have two equations, x1, y1, and a value. x2, y2 equals another value. So in order to solve the system, we will use the next determinants. We will use the whole or total determinant that will be composed by the coefficients. It says here, all the determinants are composed only by coefficients. Which coefficients? In the case of the total determinant, it will be the coefficients of x1, y1, x2, and y2. How to calculate the determinant? Remember, cross multiplication. This line is positive, this one is negative. That's why we have it here. In the case of the determinant of x, it's going to be this line that it's positive, this line that it's negative. So that's why we have this specific formula. And the determinant of y will be this one positive multiplied by minus this multiplication of these two negative. If you check out the determinant of x and determinant of y, the only thing that it changes, like in determinant of x, instead of putting the values of x, we will put the value that it's after the equal sign. And in determinant of y, it's going to be the same. Instead of having the values of y, we will put the exact values that we have after the equal sign. How then, after obtaining the three determinants, how to obtain the values of x and y? It's going to be very easy using the next formulas. X equals the determinant of x divided by the determinant of the whole system. Y will be something very similar, the determinant of y divided by the determinant of the whole system. Of course, we need to remember a little bit. If a variable is not included in the system, that means we have only x squared equals something. The value of the not included variable is going to be 0. Let's see some examples to understand better what is the Cramer method in a 2 by 2 system. So we have these systems of equations. So we need to order first our equations. So remember, the first one will be x minus 2y equals 3. It's correctly ordered. The second one is going to be 5x plus 8y equals 0. Remember, if we don't have something with the x, it's like having a number 1. I will write it here only to remember, but you don't need to write it. So after having it correctly ordered, we have or we can have the determinant of the whole system. Remember, that one is composed by x1, y1, x2, and y2. So it will be something like 1 minus 2, 5, and 8. And remember, to obtain specifically, it's going to be a cross multiplication. 1 that multiplies 8, that's the positive part. The negative part is going to be 5 that multiplies minus 2. So it's going to be 8 minus multiplied by minus, it's plus 10. So the determinant of the whole system is going to be 18. Let's obtain the determinant of x. So remember, it's going to be composed of a, b, y1 and y2. That will mean instead of putting the values of x, I will put the values that are after the equal sign, in this case 3 and 0. This one is going to be exactly the same, minus 2 and 8. So it's going to be 3 that multiplies 8 minus, and it's going to be 0 that multiplies minus 2. So it will be 24 minus 0, or plus 0, because minus multiplied by minus it's plus. It's going to be the same, 24. The determinant of y, it's going to be, instead of putting the y, we will put the values that are after the equal sign. So it's going to be 1 and 5. The other one will be 3 and 0. So it's going to be 1 that multiplies 0 minus 3 that multiplies 5. And it's going to be 0 minus 15. So it's going to be minus 15. So in this case, it's going to be, for obtaining the value of x, it's going to be the determinant of x divided by the determinant of the whole system. And for obtaining the y, it's going to be the determinant of y divided by the determinant of the whole system. So it's going to be x equals determinant of x, it's 24. The determinant of the whole system is going to be 18. I can simplify this one. I can divide by 6, and it's going to be 4/3. In the case of y, it's going to be the determinant of y, that it's minus 15, divided by the determinant that it's 18. We can divide this one divided by 3, and it's going to be 5/6. And this is going to be our actual answer in an independent way. And if we wanted to put in coordinate, remember it's always x comma y. So it's going to be 4/3 comma minus 5/6. And that will be the answer for this specific exercise. So maybe it's something very new for you, but it's also so mechanical that after doing 2 or 3 exercises, it will be super similar on every exercise. Remember, the important part is order the equations, calculate the 3 determinants we need, the whole determinant, the determinant of x, the determinant of y, and for obtaining the answer, it's going to be very easy using the formula x equals the determinant of x divided by the whole determinant, and y is going to be the determinant of y divided by the whole determinant. Let's see one other example. So let's see, for the next system, I will leave the determinants formulas there because we will use them. For the next system, remember, the first step is we need to order our equations. So the first one is going to be 4x plus 5y equals 5. The second one is going to be minus 4x minus 10y equals minus 7. So for using the values, it's going to be, the whole determinant is going to be 4, 5, minus 4, minus 10. So it's going to be 4 that multiplies minus 10 minus 5 that multiplies minus 4. So it's going to be minus 40 plus 20. So it's going to be minus 20. On the second one, for the determinant of x, remember, instead of putting the values of x, we will put the values after the equal sign, 5 and minus 7. The other one will stay the same, 5 and minus 10. It's going to be 5 that multiplies minus 10. Then it's going to be minus 5 that multiplies minus 7. So it's going to be, minus 50 plus, and it's going to be 35. So it's going to be minus 15. The other one is going to be 4 and minus 4, and instead of putting the values of y in the determinant of y, we will put the values after the equal sign. So it's going to be 4 that multiplies minus 7 minus 5 that multiplies minus 4. So it's going to be minus 28 plus 20. So it's going to be minus 8. So remember the value of x, it's going to be the determinant of x divided by the determinant of the whole system. So it's going to be the determinant of x, it's minus 15. The determinant of the whole system, it's minus 20. X equals 15 over 20. We can divide by 5 and it's going to be 3/4. After that, for obtaining the value of y, it's going to be the determinant of y divided by the determinant of the whole system. It's going to be the determinant of y minus 8 divided by the whole determinant minus 20. Y equals 8 over 20. We can divide by 4. And it's going to be y equals 2 over 5. And that will be our answer. An independent answer, if we want to put it in coordinates, remember x comma y, so it's going to be 3/4 comma 2 over 5. That will be it, the process for obtaining the answers by the Cramer method in this specific system. Let's see one other example. So let's see, if we have this system, remember the first is we need to simplify and order our equations. So on the first one, it's going to be 3x minus 3 minus 2y minus 8. I'm sorry, I forgot the equal 0. It's going to be on the next one. It's going to be 3x minus 2y equals 11. And the second one, it's going to be 2x minus 2 plus 8y equals 8y minus 10. So it's going to be actually 2x. Oh, here I forgot the minus 2 also. Minus 2. So it's going to be 2x equals minus 10. That means we don't have a value of y. So it's going to be obtaining the whole determinant. It's going to be 3 minus 2. And in the other one, it's going to be 2, 0, because we don't have a value of y on the second equation. So it's going to be 3 that multiplies 0 minus 2 that multiplies minus 2. So it's going to be 0 plus 4. So it's going to be 4. After that, we can use the determinant of x. Remember, instead of putting the values of x, we will put the values after the equal sign. The values of y stays the same. So it's going to be 11 times 0 minus, and it's going to be minus 2 that multiplies minus 10. Be aware here because we have minus multiplied by minus multiplied by minus. So it's going to be minus, because minus multiplied by minus it's plus. Plus multiplied by minus it's minus 20. So it's going to be minus 20. Then it's going to be the values of x. Instead of putting the values of y, we will put the values after the equal sign. So it's going to be 3 that multiplies minus 10 minus, and it's going to be 2 that multiplies 11. So it's going to be minus 30 minus 22, and it's going to be minus 52. So let's see. To obtain the value of x, it's going to be the determinant of x divided by the determinant of the whole system. It's going to be minus 20 divided by 4. So the values of x it's equals -5. To obtain the value of y, it's going to be the determinant of y divided by the determinant of the whole system. It's going to be y equals -52 over 4. Y equals -13. So on this case, we have the independent answer. We can put it also in coordinates, and it's going to be -5 comma -13, and that will be the answer for this system. So after seeing these three examples, you see that the Cramer method it's very robotical. After doing it maybe 1 or 2 or 3 times, it's going to be very easy for you because it's going to be always the same for obtaining the answer. So let's see other example. So let's see this one. I forgot to erase these ones. So in this exercise, we have our system. We have our specific formulas. We have our equations that are correctly ordered, so we don't need to order it. So it's going to be, on the first one, 3 minus 2, 6 minus 4. So it's going to be 3 that multiplies minus 4 minus, and it's going to be -2 that multiplies 6. So it's going to be -12 minus multiplied by minus, it's plus 12. So the whole determinant is going to be 0. After that, it's going to be, instead of putting the values of x, we will put the values after the equal sign, the values of y, -2 minus 4. So it's going to be 8 that multiplies -4 minus, and it's going to be -2 that multiplies 0. So it's going to be -32 plus 0. So it's going to be -32. After that, we can do the same with y. To obtain the determinant of y, it's going to be 3 and 6, 8 and 0. So it's going to be 3 that multiplies 0 minus 6 that multiplies 8. So it's going to be 0 minus 48. So it's going to be -48. So remember, to obtain the values of x, it's going to be the determinant of x divided by the determinant of the whole system. And to determine the value of y, it's going to be the determinant of y divided by the determinant of the whole system. So it's going to be, for x, -32 divided by 0, and for y, it's going to be -48 divided by 0. Remember, the division by 0, it's impossible to do it, so that's why we can set when the determinant of the whole system equals 0, we can set that it will be no solution for this specific system. So we don't need to do the whole process. On this one, of course, I do the whole process until here to see that it was not possible to do it. That's why the system has no solutions. But whatever, when we have the whole determinant that it's 0, maybe we can know sometimes that it will be that the system has no solutions when we have a division by 0. We will see another one when the determinant is equals 0, but we will have other kind of answer. So we will see that it's not always that when we have the determinant of the whole system equals 0, it has no solutions. Why? Let's see the other one. So what happens in this system? First, as always, we need to order it correctly, and it's going to be 12x minus 4y equals 20, and the other one is going to be 3x minus y equals 5. So if we do the determinant of the whole system, it's going to be 12 minus 4, 3 minus 1. So it's going to be 12 that multiplies -1 minus, and it's going to be -4 that multiplies 3. It's going to be -12 plus 12, that it's going to be 0. And maybe some of you can get confused and see like, okay, the determinant of the whole system is 0, so it will be no solution like in the other one. Wait a minute, because on this one will be a little bit different. What happens if we substitute the values of x with the values after the equal sign, 20 and 5, minus 4, minus 1. So it's going to be 20 that multiplies minus 1, minus, and it's going to be minus 4 that multiplies 5. So it's going to be minus 20 plus 20. It's going to be also 0. On the other one, it's going to be 12 and 3, and it's going to be 20 and 5. So let's see. It's going to be 12 that multiplies 5 minus 20 that multiplies 3, and it's going to be 60 minus 60 that it will be also 0. What will happen then? To obtain the value of x, it's the determinant of x divided by the determinant of the whole system. To obtain the value of y, it's going to be determinant of y divided by the determinant of the whole system. So it's going to be 0 divided by 0. Y, it's going to be 0 divided by 0. In this case, when we have 0 divided by 0, we can set like, because this one, remember, it comes from 0x equals to 0, and this one comes from 0y equals to 0. Any number multiplied by 0 will be 0, so that's why this specific one has infinite solutions. So remember, don't get confused that whenever the whole determinant will be 0, it will be no solutions. Of course, if the determinant of the whole system is 0, we will have the possibility of having maybe no solutions if the other ones are numbers. The possibility of exercise 5, that when everyone is 0, we will have infinite solutions for that specific system. So that was the topic of Cramer method by 2 or for 2 by 2 linear equation system. We will see each other next video.